What's going on, everyone? Flat Earthers love the Gleason map. It's on their shirts, their apps, their wall posters, even the pizza shops. But today, we're going to test it using just one city, Quito, Ecuador, and one simple idea: sunrise and sunset on the solstices. This is where the Gleason map tends to fall apart. According to Flat Earth maps, the sun moves in circles above the Earth, closer to the center in June and farther out in December. They claim this explains seasons, but if that's true, then sunrise and sunset directions and the length of the day should match what the map predicts. This here is Quito, Ecuador. It's a city with a population of about 2.8 million people. And if we put some grid lines, we can see that it's almost exactly on the equator, just 15 miles south. That makes it the perfect location to test. And here's the thing: if I'm wrong, or date and time is wrong, that's 2.8 million people who could look up, see something different, and call this out. This isn't obscure. This is basic observable reality by at least 2.8 million people. We're going to get our data from dateandtime.com. This is Quito, Ecuador, June of 2025. We have got June 21st, which is the solstice. Now, what's fun about this is we can see all the times of when everything happens, like sunrise 6:12, sunset 6:19. So what we can do is then see what the ground position of the sun is during those times. So we can see right here, Quito, date and time, and the sun is right there above Libya, Niger, Algeria, kind of between the three. And then if we look at the sunset, it is just past Hawaii over the Pacific Ocean. So let's map those. We'll turn on our sunrise and our sunset and put those right about where they should be. There's one of them. The other one, Hawaii's right there. So we're just past Hawaii. That's going to be close enough. And I did forget to put a little red dot for where Ecuador is, where Quito is. Now let's look at the sunset. So we've got December, Quito, December 21st, 6:08 a.m. and 6:16 p.m. So here we go at 6:08 a.m., just off the coast of Namibia, something like that. And then for sunset, this is going to be a little harder to nail. It's just kind of out here. No good relation to any islands. This might be on that map. So we'll turn on our two suns here, grab one of them, move it just off the coast over here, and then grab the other sun out of here. Move that, I think, about here-ish. It's going to be close to inline. These should all be relatively close to inline. This might be up a little higher than it should be. Let's drop that down a hair. It's hard because none of these shapes are the accurate shapes of any countries in pretty much anything except for maybe these. So now this is giving us a world of problems just out of the gate. The first one, it's not fully on topic with the video, is look at these shapes. This is the real shape of Ecuador here, and this is the shape Gleason's map gives for Ecuador. Those aren't accurate. Those aren't the same. So yeah, first failure of the Gleason map. So the next quick one, just with Ecuador, is sunrise in Quito is east-southeast. That means south of east. And sunset is west-southwest. That means south of west. That essentially means if somebody's in Quito looking east or west, they're looking kind of those lines. It's just above, but I'm not worried about it. So somehow, when the sun is here geographically, they're seeing it rise from here. When the sun is here geographically, they're seeing it set from over here. Again, another failure of the Gleason's map. The second you get south of the equator, it seems to get even worse. And this isn't even south. This is at the equator. So that's interesting. And then the final one, and as you can see here, this number here, this is the time that they have eyes on the sun. We can see that in June, they have eyes on the sun for 12 hours and 6 minutes. In December, they have eyes on the sun for 12 hours and 8 minutes. So, looking at the Gleason's map here, the sun moves from here to here around this circle measurably, demonstrably. We could track it in 12 hours. The sun moves around this circle here also in 12 hours. Yet, the sun's speed measurably in the sky stays the same. So on the Gleason's map, the sun has traveled I'm not going to do the math, but a quarter the distance farther in terms of distance, probably more, at the same amount of time, yet it's moving the same speed. Unless flat earthers want to say that the sun's moving substantially slower here and substantially faster there, but we don't measure it moving faster or hear it break the sound barrier while transiting. So yeah, this isn't some obscure math trick. It's observable. We track the sun, compare it to the Gleason's map prediction, and if the map was right, people in Quito would see sunrise and sunset at wildly different angles, and they would see the sun move across the sky at wildly different speeds. But they don't, because it isn't. So thank you for coming to my TED Talk on how the Gleason's map doesn't work, and the sun easily proves it on a single location. I didn't even have to compare to, then it gets nuts. If you liked it, leave a like. If you didn't, a dislike. Leave any comments in the bottom if you have anything you want me to try and debunk. And I hope you have a wonderful day.